Welcome to another flipped lesson. This is chapter 4, lesson 6. Well, if you're enjoying this chapter, it's a little more pre-calc, as we found out. I really like this lesson. It's got two things in it, and each one is helpful. It's a little advanced, okay? It wouldn't be a good pre-calculus class with at least a little advanced math. Again, we're in Algebra 3, pretty much, but it's good to throw in some advanced lessons now and then. Not overly hard, but a little bit detailed. So, thanks for tuning in today. Follow along as we go through rational equations and partial fractions. 4.6, rational equations, partial fractions. First point, just 2 points today, solving equations. We've done a lot of solving. How are these today going to be any different than what we've done in the past? Okay, you'll quickly find what is different. Let's look at our first definition. Here it is. Rational equation. One or more rational expressions that are often solved by multiplying each side by the least common denominator. Again, one or more rational expressions that are often solved by multiplying each side by the least common denominator. Notice one or more means that there's usually more than one on each side of the equal sign. So there's a variable on each side of the equal sign. And you can solve these by multiplying both sides by the least common denominator, the LCD. We'll remind ourselves what that is in a minute. That'll simplify your equation down a little bit, and it'll make it easier to solve. So again, one or more, these rational equations, or one or more rational expressions, they're often solved by multiplying each side by the LCD, or the least common denominator. All right, let's look at our first example. How are we going to solve a rational equation? Notice rational means ratio or fraction. So we're going to have variables, and there's going to be fractions with those variables. All right, it's a little more advanced. Here it is, solve a plus, here's a fraction, a squared minus 5 over a squared minus 1. Equals, there has to be an equal sign if it's an equation. A squared plus a plus 2 over a plus 1. All right, as we refer to back in NOM, that right there, my friend, is a hot mess, okay? In other words, it's a lot of A's going on there. We're trying to find what A equals, okay? If you're back in 8th grade, and some of you like to solve problems in your head, just look at a plus 7 equals 15 and say, oh, A is 8. Well, not the case now. Okay, it'll take you a very long time to go through all your options and find what A equals. But that's what we're trying to do. We're trying to solve for A. Notice, looks a lot different than anything we've encountered thus far in our mathematical journey here at Bible Baptist. Because there's lots of A's and there's fractions. How do we solve? Let's go back to our definition, read it. Hopefully it's in your notes now. One or more rational expressions are often solved by multiplying each side by the LCD. What's the LCD? The least common denominator. Okay? It's going to be, the LCD is really, it has to include all of your denominators. In other words, it's called the least common, so it's a little confusing. But in a way, it has to be like the biggest denominator has to include everything. In other words, what's the denominator here? 1. Denominator here, a squared minus 1. Denominator here, a plus 1. Your LCD has to include everything. It has to include 1. We won't write that. That's in everything. 1 times whatever. It has to include this and this. Now, what do we notice about these? Well, hopefully now, by the time we're in 12th grade, we recognize this is a difference of squares. In other words, if I were to factor this down, a plus 1, a minus 1, right? FOIL this out, a squared, middle term cancels out, minus 1. So this is the same thing as this. In other words, notice, these are the same. So the best LCD for this problem is just this, because that includes 1, and it also includes this denominator, a plus 1. You could write this, okay, we're going to condense it, and we'll just write a squared minus 1. That's our LCD. Okay. Again, each problem is going to be different. The key is it has to include all of your denominators. What do we then do? Well, we take our LCD and multiply it by both sides. So let's write that. A squared minus 1 times the left side. A plus A squared minus 5 over A squared minus 1. I took my LCD times this whole left side. Same thing for the right side. A squared minus 1 times the whole thing. A squared plus A plus 2 over A plus 1. Again, be writing this information down. You want to have it in your notes. All right, how do I multiply? Notice I wrote it kind of in the upper portion, upper spot. Why is that? That helps us remember that there's a 1 underneath. Okay? You can write that in if you want, just to kind of help clarify. Remember, fraction times fraction is multiply across. A squared minus 1 times A. Distribute. A cubed minus A. Okay? That takes care of this first portion. Notice, because it's something multiplied, I have to distribute it to both. Let's draw arrows here. Multiply here and here. So when I multiply A squared minus 1 times A, I distribute the A cubed minus A. What about here? What happens? Notice, A squared minus 1 over A squared minus 1. That's why we do the LCD. We're going to get some canceling out here. It's going to be a little easier. We had to multiply to the first one because it couldn't cancel. The second one could cancel. We're just left with this. A squared minus 5. That's my left side. Notice, it's a lot easier than what we started with. No more fractions. What about over here? Equals. We just have one term here. Remember, terms are separated by a plus or minus sign. Now, we do have plus and minus signs here, but it's all divided. So it's all one big term. Can these cancel? Initially, no, but kind of. Remember, this is A plus 1A minus 1. Let's rewrite that. Let's cross that out. And let's write A plus 1A minus 1. It's the same thing, it's just factored down in a different form. All right, now what can we do? We can cancel the A plus 1s. So what are we left with? This times that. Now how do you do that? Let's write that out here and I'll show you. A minus 1, A squared plus A plus 2. How do I do that? You may say, FOIL. No. FOIL is only when you have a binomial and a binomial. What is that? Trinomial, right? 3 terms. So how do I multiply a binomial times a trinomial? Pretty much it's just big distributed. Take the first term times everything. Take the second term times everything. You're gonna have one long bucket hot mess. All right, here it is. A times A squared is A cubed. A times A squared plus A times 2, 2A. That was my first term. A times A times A. And I gotta do the second term, 1. It's really just gonna change the sign of each one of these, right? Negative 1 times A squared is negative A squared. Negative 1 times A, negative A. Negative 1 times 2, negative 2. Okay, still long. Why is it better? No fractions. Don't forget about this left side here, recopy. A cubed minus A plus A squared minus 5. What are we trying to do? We're trying to solve for A. Looks still pretty sketchy, but you're gonna see it actually works out pretty well. Before I move up here to some more room for me on the board, let's see what we can cancel. I'm trying to get A all by itself, right? So I can switch things on either side of each other. A cubed, what's gonna happen there? If I subtract A cubed from both sides, subtract minus A cubed, they cancel. Okay? What else could we do? Let's look over here. Plus A squared minus A squared, cancel. Okay? That's good for now. Let me darken that up a little bit. We canceled there, 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 and there. It really doesn't matter what you do in a certain order, but as long as you're following the math rules, it'll work out. Let's recopy now up here. Negative a plus a squared minus 5 equals 2a minus a. What does that give us? 2a minus a is just plus 1a. So plus a minus 2. All right, it's looking good. Let's see what happens. Let's try to get everything on one side and set it equal to 0, because it doesn't look like everything's going to cancel out. Subtract a. Subtract a. What does that give us? Negative 2a. Add 2. So a squared doesn't have any friends there. This gives us minus 3 equals 0. What have we here? Let's rewrite it in the proper form. A squared minus 2a minus 3 equals 0. Everything didn't cancel out, unfortunately. How do we solve for a? 4 methods. Graphing, factoring, completed square, quadratic formula. Which one is the best, you may ask? It's up to you. We prefer factoring. It's quick as it's the easiest. Secondly is probably quadratic formula, if you remember it. And then completed square and graphing. Let's see if it factors. If it does, we'll do that. If not, we'll have to do probably quadratic formula. Does it factor? The first term is just a times a is a squared. How do you factor? Hopefully you remember. What two numbers multiply to be a negative 3? Add or subtract to be a negative 2? Well, we only have one option for 3. It's 1 and 3. Could that give us a 2? Sure. What would the signs have to be? Negative 3, positive 1. If we multiply that out, it would give us a negative 3. It would also give us negative 3a plus 1a, which is negative 2a. What are we trying to do? What does that mean? What is my answer? What's the number that equals a that would make the statement true? Pretty much done. How do I do it here? Set both of these binomials equal to 0, or just take the opposite sign. A equals negative 1 and positive 3. Those are my two answers, negative 1 and 3. If I plug either of those into a here, the statement would be true. In my notes, it says check solutions. Let's do it real quick. Let's just do one of them. Negative 1 or 3. Which one do you want to do? What's that? Negative 1. Good call. Plug it into here. We'll go up here. Negative 1 plus negative 1 squared minus 5 over negative 1 squared minus 1. Notice I'm going into the original equation. Also have to do it here. Negative 1 squared plus a negative 1 plus 2 over negative 1 plus 1. Let's shake all that out. Hopefully the statement's true. Negative 1 stays by itself. Negative 1 squared is 1. 1 minus 5 is negative 4. Over, let's do a plus in there. Negative 1 squared is 1, minus 1 is 0. Okay, keep going. Negative 1 squared is positive 1. Minus 1 plus 2 is a plus 1 over 0. Negative 1 plus, what is that? Over 1 plus 1 over 0. Negative 4 over 0 and 2 over 0. That, my friends, is undefined, not possible. You always want to check your solutions with these rational equations. Sometimes what happens is you get an answer that looks correct. We did all the work right. When we checked it, it didn't work out. Negative 1 is not an answer. Does not check. This is not a number. This is not a number. Negative 1 equals nothing. Undefined. Nothing. Can't happen. Okay? 3 does work. Okay, if we were to plug a 3 in here, it would check out. Okay, for sake of time, we won't. But you will want to check all of these. I will try to remind you on the instructions on the test or quiz. But for all of these rational equations, you're going to want to check. Because sometimes a solution that appears to be true is not true. And again, the undefined is really going to be your key. That is solving rational equations. Not overly hard. Here's the key. Key is the LCD. Find the LCD, multiply both sides of the equation. You will get an answer then. You'll get an equation that is simpler. Now again, we still do some work, but it wasn't crazy with all those fractions. Okay, most of the time all your fractions are going to cancel out. That is step 1 of this lesson. Hopefully they're written down. I'll give you another second. We're going to look at step 2. Okay, step 2 is called decomposing fractions. Now you may say, decomposing. I've only heard that word on NCIS in relation to bodies. Well, we are not decomposing bodies today. We are in fact decomposing fractions. What does decomposing mean? A little English test here on this math flipped lesson day. Decompose. Break down. Change forms. Disintegrate. In terms of body, since we're on that morbid thought, in terms of bodies. Decompose would mean to break down, right? Change in a different form. If your body is decomposed, you are probably not alive because it is in a different form and worms have begun to eat you. So decomposing fractions means we're just taking a fraction, changing it. We're putting it into a partial fraction. Here's step 2 of this lesson. Decompose fractions. Break it down. Partial fractions. Okay. Here's our definition under decomposed fractions. Here it is. Partial fractions. Decomposing fractions into separate parts that add or subtract to equal the sum. Decomposing fractions into separate parts, so 2 different parts, that add or subtract to equal the sum. Okay, so we're decomposing, we're breaking down fractions into 2 separate parts or more, but usually 2 separate parts that are going to add or subtract to equal the sum. This process includes some steps, so we're actually going to write down the steps for you in red as well. But get down that definition in red one more time. Partial fractions is the name of the definition. Decomposing fractions into separate parts that add or subtract to equal the sum. So, let's look at our example. Here are the directions. It says decompose 8y plus 7 over y squared plus y minus 2. Decompose that into partial fractions. So we're not solving, we're changing the form. Now you may ask, why do we need to do this? Okay, our book has a nice sentence that tells us why. Decomposing fractions is a skill used in calculus. We're kind of in that, right? We're in pre-calculus, almost calculus. And other advanced math courses. In other words, you're going to have to use this process, if not in the future this year, which it may come up again, potentially in your future college classes. Some of you think, well, I'm not going to take math in college. Sorry to break it to you. You have to, most majors make you take at least 2 math classes. Some majors that you think don't include math, business. Other majors that are very popular make you take calculus, at least 1 semester of calculus 1. So you may have to use this again in the future, and it's a good skill to know, at least have an idea of how to decompose or find partial fractions. Okay? So decomposing 8y plus 7 over y squared plus y minus 2, decompose that into partial fractions. All right, step 1, we're going to take our red pen. Let's use some red here and list down these steps. Step 1, first thing we have to do is factor the denominator. Every denominator of these partial fractions will factor, okay? Somehow, some way. Every denominator will factor. So, first step is to factor that denominator. How do we do that? Well, we look at the denominator and say, does it factor? Let's do it here underneath step 1. Y squared plus y minus 2. What does that factor to be? It's a pretty easy one. Quick note, they all will be pretty easy. Won't be too advanced. Once you know it's multiplied to give me negative 2, add or subtract to give me plus 1, 2 and 1. Which one's negative? That one. No. That one. Because we need a positive 1 in here. Y plus 2y minus 1. It's our first step. Step 2. Now that we have the factored form, express the factored form as the sum of two fractions using A and B as numerators. Okay, a couple words, let's remind ourselves what they mean. Factored form, that's what we just did. Sum, that means we're adding them up. Two fractions, adding two fractions. Using A and B as numerators. What does numerators mean? Top line of the fraction, right? So, what are we going to do? How are we going to write that? Well, we're going to take our original equation, 8y plus 7 over y squared plus y minus 2, and express that as the factored form as the sum of two fractions. A and B are our numerators. So here's two new fractions. A and B are the numerators. What's the denominators? The factored form of this original denominator, of the original base. Doesn't matter which one's which. Let me follow my notes here. I had A as y over 1, B as y over 2. Again, doesn't matter which one's which. It'll still work out. But for this case, let's do it this way. All right, that's step 2. How many steps you may ask? A couple more. Step 3. Eliminate denominators using LCD. Eliminate denominators using the LCD. What's the LCD? We just reviewed it earlier in this lesson. It has to be the denominator, the base, that includes everything. Here's our new equation. What is the denominator that includes everything? Well, this factored is exactly like this. In other words, if we use this as our denominator, or our least common denominator, it will cancel out, or it will include both of those as well. How do we eliminate them using the LCD? That's what we just did last step. In a sense, you take this whole thing and multiply it by your LCD. Y squared plus y minus 2. Again, that's my LCD. That is what is included in each of these denominators. When I multiply by this first term, the whole thing cancels. I'm left with 8y plus 7. That's nice. I took a huge kind of problem down to just the top because these both cancel out. What did we say this was as factored form? Y plus 2, y minus 1, right? That's what that is. So what happens when I take this times this first term on the right side here? Y plus 2 minus 1, y minus 1 times this, what happens? The y minus 1's cancel, and I'm left with this, y plus 2 times a. Okay, we have one more term that this LCD has to be multiplied by. What happens when I multiply y squared plus y minus 2 times this term? The y plus 2's cancel. That leaves me then with y minus 1. Y minus 1 times b. Notice what happened. Most of us do not like fractions. We have gotten rid of our fractions, again, using the method we just used earlier today with the LCD. Went from a huge problem, initially a pretty big problem, and then it got even bigger, but then by doing it this way, and multiplied by the LCD, our denominators are gone. We eliminated them. We're almost done. Step 4 and 5 are the two keys here. They're pretty much the same. What is step 4? Again, we're giving you these steps. These aren't going to be given to you on a test or quiz, but you'll have to know them. It's pretty straightforward. You'll understand and figure out the sequence as we go, but I thought I'd write it out for you. Now, what do? Eliminate either A or B, because notice what's going on here. We got a lot of unknowns. We have the unknown of Y. We also have an unknown of A and B. It's too many unknowns. Okay, so we got to break it down a little bit. We're going to eliminate either A or B by making parentheses equal 0. In other words, let me explain that step. Look what we're talking about. A times y plus 2. What happens if we make this parentheses here? What happens if y plus 2 all of a sudden becomes 0? A times 0 is 0. That whole thing's gone. That's what we want to do. We want to eliminate either A or B by making these parentheses equal 0. Now, we're going to have to do it in 2 different steps because they're different. But that's the idea. Let's start out with, doesn't really matter. Let's eliminate B, which means we're solving for A. So on the left side here, let's write solve for A. Eliminate B. Okay. How would we eliminate B? What do we have to let y equal? If I want to get rid of B, what does y have to equal? In order to make this 0, what does y have to equal? Positive 1. If this is 1, 1 minus 1 is 0. 0 times b is 0. So let's let y equal 1. If I do that, it has to be true for the whole equation. So I get 8 times 1 plus 7 equals a. Y is 1, we said, plus b. Y is 1. Let's solve. Notice what happened. In a minute, that's going to be 0, and we're going to have one unknown. 8 times 1 is 8, plus 7 is 15. 1 plus 2 is 3, times a is 3a. 1 minus 1 is 0, times b is 0. Trying to solve for a. 15 equals 2a plus 0. How do we solve for a? Divide by 3. A equals 5. 5 equals a. That's half. Find b and we're done. Step 5. Eliminate the other numerator. Remember, numerator means the top part of the fraction by same method. Eliminate other numerator by same method. We're almost done. Thanks for sticking with us. I know it's a little longer today. Solve for b, eliminate a. How do we eliminate a? Again, back to our original here. How do we eliminate a if we're solving for b? How do we get a to be 0? Y has to be -2. Let's plug in -2 for each spot of y. 8 times -2 plus 7 equals a times -2 plus 2 plus b times -2 minus 1. Notice all my variables are going to be gone here, men, except for b. -16 plus 7 is -9. -2 plus 2 is 0. A is gone. -2 times, or minus 1 is -3b. How do I solve for b? Divide by -3. B equals 3. Now, well, those are answers. What are we trying to find? Let's review. We're trying to decompose into partial fractions. This right here is partial fractions. The problem is we had too many unknowns. Now we know what a is. It's 5. We know what b is, it's 3. That's our answer. Plug them back in, and that's our partial fractions. I wrote down step 6. Let's do it over here, hopefully you can see it. Step 6. Substitute values. Substitute, abbreviate there. Substitute values for a and b to determine partial fractions. Okay. Here's what we had for our partial fractions. Let's write it. A over y minus 1 plus b over y plus 2. What did we say A was? 5. What did we say B was? 3. Our answer, 5 over y minus 1 plus 3 over y plus 2. We have found our partial fractions. Okay? We don't want to go backwards, but if we did, if we were to multiply these together, what would we need? We need a common denominator. We'd multiply them out. We'd combine the top. Guess what happened? We'd go right back to here. We broke down this big rational equation, right? It's an equation that is in a fraction with variables. And we broke it down into 2 fractions that are a lot simpler. 5 over y minus 1, 3 over y plus 2 is a lot simpler and easier to use, again, in future areas of math, especially calculus. And this is the process. So 6 steps, not overly difficult, okay, but a lot to keep straight. Hopefully you wrote this down. We decomposed the given equation to partial fractions. That is it for section 6 of chapter 4. Thanks for tuning in. Hopefully you found Freddie and you're having a great day. We will see you next time.